This lecture is a continued discussion of evaluation of text categorization. Earlier, we have introduced measures that can be used to compute precision and recall for each category and each document. Now, in this lecture, we're going to further examine how to combine the performance on these different categories or different documents. How do we aggregate them? How do we take average? Now you see on the title here, I indicated it's called a macro average, and this is in contrast to micro average that we'll talk more about later. Right? So again, for each category, we can compute the precision recall and F1. So for example, for category C1, we have precision P1, recall R1, and F value F1. And similarly, we can do that for category 2 and all the other categories. Once we compute that, we can aggregate them. So for example, we can aggregate all the precision values for all the categories to compute the overall precision. And this is often very useful to summarize what we have seen in the whole data set. And the aggregation can be done in many different ways. Again, as I said, in case when you need to aggregate different values, it's always good to think about what's the best way of doing the aggregation. For example, you can consider arithmetic mean, which is very commonly used, or you can use geometric mean, which would have different behavior. Depending on the way you aggregate, you might get different conclusions in terms of which method works better. So it's important to consider these differences and choosing the right one or a more suitable one for your task. So the difference, for example, between arithmetic mean and geometric mean is that the arithmetic mean would be dominated by high values, whereas geometric mean would be more affected by low values. And so whether you want to emphasize low values or high values would be a question related to your application. And similarly, we can do that for recall and F-score. So that's how we can then generate the overall precision, recall, and F-score. Now, we can do the same for aggregation over all the documents, right? So it's exactly the same situation. For each document, we'll compute the precision, recall, and F. And then after we have completed the computation for all these documents, we're going to aggregate them to generate the overall precision, overall recall, and overall F-score. And these are, again, examining the results from different angles, and which one is more useful will depend on your application. In general, it's beneficial to look at the results from all these perspectives, and especially if you compare different methods in different dimensions, it might reveal which method is better in which measure or in what situations. And this provides insight for understanding the strengths of a method or weakness, and this provides further insight for improving them. So as I mentioned, there is also micro averaging in contrast to the macro average that we talked about earlier. In this case, what we do is to pull together all the decisions and then compute the precision and recall. So we can compute the overall precision and recall by just counting how many cases are in true positive, how many cases in false positive, etc. Basically computing the values to fill in this contingency table. And then we can compute the precision and recall just once. Now, in contrast, in macro averaging, we're going to do that for each category first, and then aggregate over these categories, or we do that for each document, and then aggregate over all the documents. But here we pull them together. Now, this would be very similar to the classification accuracy that we introduced earlier. And one problem here, of course, is to treat all the instances, all the decisions equally. And this may not be desirable, but it may be appropriate for some applications, especially if we associate, for example, the cost for each combination. Then we can actually compute, for example, weighted classification accuracy, where you associate the different cost or utility for each specific decision. So there could be variations of these methods that would be more useful. But in general, macro average tends to be more informative than micro-averaging, just because it might reflect the need for understanding performance on each category or performance on each document, which are needed in many applications. But macro averaging and micro averaging, they are both very common, and you might see both reported in research papers on textual categorization. Also, sometimes categorization results might actually be evaluated from ranking perspective. Now, and this is because categorization results are sometimes, or often indeed, passed to a human for various purposes. For example, it might be passed to humans for further editing. For example, news articles can be tentatively categorized by using a system, and then human editors would then correct them. Right? Or the email messages might be routed to the right person for handling in the help desk. And in such a case, the categorization is to help prioritizing the task for a particular customer service person. Right? So in this case, the results have to be prioritized. And if the system can give a score to the categorization decision or confidence, then we can use the scores to rank these decisions and then evaluate the results as a ranked list, just as in search engine evaluation, where you rank the documents in response to a query. So for example, a discovery of spam emails can be evaluated based on ranking emails for the spam category. And this is useful if you want people to verify whether this is really a spam. Right? The person would then take the ranked list to check one by one and then verify whether this is indeed a spam. So to reflect the utility for humans in such a task, it's better to evaluate the ranking accuracy, and this is basically similar to search again. And in such a case, often the problem can be better formulated as a ranking problem instead of a categorization problem. So for example, ranking documents in the search engine can also be framed as a binary categorization problem, distinguishing relevant documents that are useful to users from those that are not useful. But typically we frame this as a ranking problem and we evaluate it as a ranked list. That's because people tend to examine the results sequentially. So ranking evaluation more reflects the utility from a user's perspective. So to summarize categorization evaluation, first, evaluation is always very important for all these tasks, so get it right. If you don't get it right, you might get misleading results, and you might be misled to believe one method is better than the other, which is in fact not true. So it's very important to get it right. Measures must also reflect the intended use of the results for a particular application. For example, in spam filtering and news categorization, the results are used in maybe different ways. So then we would need to consider the difference and design measures appropriately. We generally need to consider how will the results be further processed by a user, and then think from a user's perspective what quality is important, what aspect of quality is important. Sometimes there are trade-offs between multiple aspects like precision and recall, and then so we need to know for this application is high recall more important or high precision is more important. Ideally, we associate the different cost with each different decision error, and this of course has to be designed in an application-specific way. Some commonly used measures for relative comparison of different methods are the following. Classification accuracy is very commonly used for especially balanced test set. Precision recall and F-scores are commonly reported to characterize the performances in different angles. And there are some also variations like a per document based evaluation, per category evaluation, and then take an average of all of them in different ways, micro versus macro averaging. In general, you want to look at the results from multiple perspectives. And for a particular application, some perspectives would be more important than others. But for diagnosis analysis of categorization methods, and it's generally useful to look at as many perspectives as possible to see subtle differences between methods or to see where a method might be weak, from which you can obtain insights for improving a method. Finally, sometimes ranking may be more appropriate, so be careful. Sometimes categorization task may be better framed as a ranking task. And there are machine learning methods for optimizing ranking measures as well. So here are two suggested readings. One is some chapters of this book where you can find more discussion about evaluation measures. The second is a paper about the comparison of different approaches to textual categorization, and it also has an excellent discussion of how to evaluate the textual categorization.